Assalamualaikum warahmatullahi wabarakatuh and good day everyone. My name is Ahmad Syukur bin Jalaluddin and these are my team members and we are from group Hyperthreading and we'd like to introduce regarding our project which is OPT and LRU. Well, since as we know, memory or RAM is limited and expensive. Thus, as time goes by, we need to multitask things in our future in our daily life. Thus, using just physical memory would not be sufficient for us to implement many multitasking things. Thus, here where we will implement the virtual memory concept to allow a larger address space compared to physical memory. Virtual memory is implemented where only part of the program is loaded into the memory for the implementation. And virtual memory, there are a few ways for us to implement it, and one of the way is using demand paging. Virtual memory references to the physical memory, and all the references are mapped in the page table which resides in the main memory. Next. As we know, we cannot load everything in the main memory. Thus, some part of the program will be in the backing storage. How do we know if the part of the program is in the main memory or in the backing storage? Here is where we will use valid invalid bit inside the page table. If it is valid, it will just take the page from the main memory. But if it is invalid, then the trap will occur and page fault will also occur, where the operating system will find the space needed in the backing storage and bring it into the main memory to be referenced by the logical memory. But let's say if the main memory is full, then how are we going to insert it? We need to sacrifice a page. And how do we choose to sacrifice a page? It is where we will use OPT or LRU algorithm in order for us to insert our new page by sacrificing an old page. Thus, that will be explained by my friend Muhammad Yas.
Alright, thank you, Shuko. So the most desirable page replacement algorithm is the optimal replacement algorithm, also known as OPT, which we use to replace pages. So how does this algorithm works is that this algorithm replaces the page with the lowest future demand when compared with the other frame page. To accomplish this algorithm searches for a page from the reference that will be not used first and consider that page useless for the time being, and new page in the frame takes its place. One of the advantages using this algorithm is that this algorithm replaces the page will be not used for the longest time in the future, resulting in the least number of page faults. Next slide, please. So as we can see in this example is that in the first frame, 7 will be replaced by 2 because it will be used in far future. Similarly, in the second frame, 0 will be replaced by 4 because it will be used in far future comparatively 2 and 3. So the demonstration of how we relate OPT with real life application will be presented by Muhammad Qayyim.
Now, I will be explaining about the OPT coding for our car rental system. So inside our main program, admin will be asked to enter the queue of car renter as in string without any space. Like in the example given, A will be the first person who rent the car, followed by B and then C. Next, we will be counting the number of people who rent the car, and then we will be passing the parameter inside our OPT function, people who want to rent the car array, and the number of people who want to rent the car. Moving on to our OPT function. So first we initialize the getCar array. The getCar array represents frame in OS term. So we have 3 frame because we have only 3 car inside the shop. Okay, so from line 130 to 152, it is to insert the 3 first key of car renter into the getCar array or frame without any duplication, because as we know, if we already have data inside the frame 0, that data, the same data cannot be in another frame. That's why we do this coding. Okay. Next, the code below from 159 to 176, we will be traversing through each character inside the current array to assign frame to the next character in the array that will be replacing data inside the frame. Okay. So in the line 163, we want to check whether the current iteration inside the current array or person who needs to rent the car is already inside the get car array. If it is already inside the get car array, we will just skip the iteration of the loop. Alright, Next, in the line 176, we will just printing the person who are currently renting the car will be frame 0, frame 1, and frame 2. Alright, in the line 168, we will be checking, we will be passing the index for the person who till next rent is the longest and pass the index into our in longest count renter. Okay, now let's go check the check longest time function. The check longest time function, first we represent frame 0, frame 1, and frame 2 as person A, person B, and person C, just to add more clarity. Alright, and then from line 22 to 50, this line is to check which data inside the frame has the longest count till next iteration of the same data. Okay, if the data cannot be found in the next iteration, we will just assign high number to it so that it will be replaced. But in this line from 60 to 73, if the data cannot be found and the data inside the frame, if there are two data inside the frame cannot be found, we will be doing this coding, which the first data to be accessed will be removed first. And then from the line 79 to 97, we'll be calculating and determine which data inside the frame have longest count till next run. So basically this coding here is to calculate which of the three data inside the three frame is the longest. And then from line 103 to 114, we just assign index of data with the longest count till next run into an integer to lastly being written by this function here. In the line 116, we will be returning the index of the data inside the getCar array, which have the highest duration till next run. Alright, so moving back onto our coding inside the OPT function, after we have getting the index of the longest till next run, person who longest till next run, we will be printing the next person in the iteration, the next person who want to rent the car will replace get car and the index that we get earlier in renting the car. Okay, and then this coding here is where the OPT happened. We will be assigning the next person to rent the car into the car that is currently holding the person whose duration till next rent is the longest. This is where the swapping happened. And then lastly, we will be printing the last three person to rent the car will be inside the frame 0, frame 1, and frame 2. Now I will be running the program to show how the OPT code is being implemented. Okay, let's move on. Okay, this is our program. The first thing we need to do is to enter string without any space. I will just enter any random word. C, B, A, D, E, F, P. Okay. The first three that get to rent the car is person A, person B, and person C. Even though there are duplication of A word here, the system already detected the duplication and therefore will not allow any duplication inside our frame. And here it states that A will next rent car the letters and D will replace A. This is because B and C, as we can see here, is very near their next iteration. But for A, its next iteration is until here. Therefore, it's very far away. Therefore, D will replace A rather than replacing B and C. The same goes for all the iteration that happen in the next three times here. And lastly, it will show the last three person to rent the car. That's all from me. Thank you.
So thank you, Muhammad Qayyim, for the demonstration. So the next algorithm we have is LRU. The least recently used LRU algorithm is a memory management technique that uses page replacement method. This method replaces the page that has been visited the fewest time. As a result, any page that has been unused for a longer period of time can be either replaced in the memory. The LRU page replacement policy is based on the observation that pages that have been heavily used in the previous instruction will most likely to be heavily used again in the following instruction. Pages that have been not used in a long time, on the other hand, are likely to remain inoperable for a long time. Next slide, please. So further explanation on LRU is that 7, 0, and 1 will result in a page fault first. So reference for page 2 will generate a page fault as page 2 is not available in the memory and swapping is required according to LRU. So page 7 will be replaced by page 2 and reference for page 0 will generate no page fault as it is already available in the memory. Similarly, all the reference will be checked against the availability pages in memory and the page reference string to find out the least recently used page. And the demonstration of how we relate this LRU algorithm with real-life application will be presented by Muhammad Faiz and Haris Izzuddin. Thank you.
Thank you, Rias. So I will explain about the least recently used algorithm. Okay, so basically in this project, we propose a system which is the book management system by applying the LRU concept. Okay, so next. Okay, so the objective of this system is to manage books is an efficient and useful way. So basically, the system applies the LRU algorithm to minimize the number of page faults and optimize the usage of memory. Okay, this system will allow the admin to see all the books in the list, along with the last day each book was accessed. Okay, so this feature enables the admin to identify which books are the least recently used and decide whether to delete or replace them with other books. Okay, so this is similar how LRU algorithm works in memory management, where the oldest unused page are replaced with a new page. Okay, so next.
Okay, I am Haris Zudin and I will do the demonstration on our system, which is book management system. Okay, let's jump to the demonstration. Okay, we can see here our system have 5 options. So we choose one to view book in the list. So as for your information, our list can contain only 5 books at the same time. So we can see from here that there are 5 books in the already in the list. Okay, let's see if we wanted to insert new book, what happened to the system. Okay, the system tell that we have reached the limit, so we need to remove a book first. So we need to remove a book. So by implementing the concept of LRU, we need to choose the Lord of the Ring because this book is not being used for 18 days, which is the longest time. So which is the Lord of the Ring. Okay, now the book has been removed from the system. We can choose number 4 to display the book. Okay, we can see the book has been deleted. Okay, now let's insert the new book. Okay, we need to provide the book title. Here I want to insert book name Harry Potter. Say, and the author is, as we already know, J.K. Rowling. Then the entry date we use today, 2023. Okay, the system tells us that the new book has been added. So we can see the list. Okay, as we can see, Harry Potter is on the bottom of the list. Okay, I think that's all for the demonstration. So in conclusion, the idea of optimal replacement algorithm used for page replacement is to replace the page that has low demand in the future with a new one. On the other hand, the concept of LRU is to replace the page that are not being used for the longest time with a new page. There are so many situations that we can also implement these two algorithms, which are OPT and LRU. But we are hoping that your understanding about OPT and LRU can be more clear from the two scenarios that we showed in the demonstration. I think that is all from us. Thank you.
Thank you, everyone.